let's start with the introduction of our fluid mechanics. Fluid mechanics will define from the book, where it is the physical science dealing with the actions of fluids at rest or in motion. So we have on and with applications and devices from the engineering using the fluids mechanics. So we have all two, we call this branches of fluid mechanics. We have fluid statics, which deals with the fluids in stationary, and we have another type is the fluid dynamics. So this will really deal with the fluid in motion. This is fluid in fluid statics, fluid in stationary. Okay. While fluid in dynamics studies in the fluid in motion. So this is for mechanical application. This plays a vital part, or call this basic foundation need to understand as you go along sa engineering courses ninyo. So basically, more application ito. Pagkatapos ng fluid mechanics, it will be a fluid machinery. So that is the designs of pumps, turbines, engines. So it deals with all the fluids that is moving. So mostly kasi in terms of we call this steam turbine or steam power plant. So we using steam as a medium in order to generate power. So you need to understand what are the properties of fluid. So how you going to use the properties. So it will be karagdagang kaalaman para ma-expand niyo yung calculation niyo. And you will be kagandahan kasi is if you know the properties of fluid, you can able to determine yung how much the quantities or how much magiging properties niya in terms na pag may change in temperature. So for example, yung water, no? So usually yung H2O or yung water, so at normal temperature, normal temp and pressure, so ang properties niya, so usually ang bigat niya, so that is in the density. So yun, later on we'll talk about the density. So yung bigat niya is usually that will be 1,000 kilogram. That will be 1,000, no? Density, that will be 1,000 kilogram per cubic meter. So that will be the density of water. Now, if you're going to change the temperature, or you're going to change the pressure, or let's go to temperature now. If you're going to change the temperature class, so the properties of water, so usually density niya gumagaan, especially mapapansin nyo as it changes the properties from liquid to steam. Okay, so the properties of the density of the fluid changes. So you will notice here from water it changes to steam. So though these characteristic properties of water, magkaiba na sila in terms of steam. And also the enthalpy, internal energy. So it will be talked about sa pag-usapan na later on sa ano niya. Call this thermodynamics too. Okay? But those properties changes as also that's the properties ng tubig natin. So that kaya nag-play siya ng vital role sa basic foundation ng engineering subjects. And we have the types of fluid. So we have your ideal and real fluids. So, to this ideal fluids, so it's defined as assumed to have no viscosity and hence no shear resistance to shear and no resistance to shear. So mostly kasi if we have the proper, usually yung kumbaga sa Tagalog yung viscosity, that is yung how much yung kumbaga parang ano yan, to explain it in layman's term, parang lapot ng tubig. Okay? Usually water have a viscosity properties, but ang lapot niya is so magaan o mababa ang viscosity index niya. So that's why malabnaw, or let's say just flow like a simple water, or hindi compare to mantika or oil. So makikita niyo yung viscosity, yung lapot niya. So in layman's term. So yun yung makikita niyo yung properties ng the more nagiging malapot yung fluid, the higher the viscosity properties or viscosity index ng fluid natin. So that explains yung viscosity. So that is in a layman's term. So baka hindi nyo pa na-encounter, but in real life that will be the layman's term. Then we have incompressible. So when we say incompressible, so that is yung cannot be compressed. So when we say cannot be compressed, that is for example, you have a piston. If you have a piston in a cylinder arrangement, if you have here your cylinder, no? So you have here your cylinder and you have here your piston and the fluid is here. So when we say you're going to compress, it is incompressible, it cannot be compressed. So matigas, it's hard. Compared sa, mapapansin nyo, if you're going to put here an air is actually can be compressed, but water, we call this water, oil, or uncompressible properties. And then we have another properties. So we have another properties yung have a uniform velocity when flowing. Okay? So have a uniform velocity when flowing. So for example, ang explanation yan, we have here, for example, this is your pipe, no? So when we say uniform velocity, so usually yung fluid mo dito, fluid mo here, are unequal in terms of velocity. When we say velocity, ano yung unit ng velocity? Mostly that will be in SI, that will be meters per second. So how much is the speed? This is constant. But in actual, so usually it varies. So parang nagkakaroon kasi yan, usually the fluid travels in a form of a oval shape, ang gula niya. And they have different velocities in actual. So this is ideal, have a uniform velocity. But mostly, yung gagamitin natin class, that will be have a uniform velocity, because we need to use an ideal in order to create their solutions. So one of the ways you can predict that something is in actual is basing your solutions in ideal. So then another property is, if we have another characteristic ng ideal is no friction between moving layers of fluid. So how do we going to explain this one? So if you have a pipe here, so there will be no friction reaction between another layers or moving layers or adding layers. So that is different layers here. So between this fluid or with this line, there will be no friction. So it can easily flow. Okay? So that explains the no friction between moving layers. Then we have no eddy currents or turbulence. So when we say eddy current or turbulence, for example, this is your pipe. Usually you have a uniform flow, equal. Eh? Now, if you have a turbulence, usually that is inequal. So turbulent, the flow of water is something like this, rumbling like this. Okay? So they have a different form of direction. So kung sa layman's terms sa Tagalog, magulo ang type of flow niya. That is the turbulence. Now, in ideal, there is no turbulence. Okay? Then for real fluids, it is an opposite ng ideal. So it exhibit a viscosity. So in layman's term, that will be parang may lapot siya. No? So layman's terms, in Tagalog term, may lapot siya. Then we have non-uniform velocity distribution when flowing. So non-uniform, so opposite din nung kanina. So when we say non-uniform, if you have your pipe here, so yung flow niya magulo. Okay? So rampage. So when we say it's an opposite ng kanina. Then we have compressible properties. Then we have experience friction and turbulence and flow. So that is also the explanation ng ideal, opposite explanation ng ideal fluids. And so it is symbolizes with the letter rho, and it is defined by the equation that will be the mass of the fluid divided by the volume, or we can represent it by equation that will be N is for mass and you have your V is for your volume. Now for your SI units, so for SI units usually makikita nyo, it will be in terms of kilogram per cubic meter, no? Or in English unit, it is, we have pound mass, okay? Then divided by cubic feet, or only can be represented as pound mass, or pound or cubic inch. It is in the unit terms of cubic. Now for an ideal gas, so its density can be formed from the specific gas constant and the ideal gas law. So if you still remember from your thermodynamics, we have the equation from your thermo, that will be PBMRT, no? So you're just going to derive the equation in order for you to have this form of equation. So that will be to compute the density. So you need to equate, derive your equation like this. So that will be P divided by your RP, when then you have your mass over your volume, so that will be equal to the density of your air. So this is for your air lung properties. Now for liquid, liquid like water, oil, so we'll be using this mass over the volume. Or it can be also used in also in terms of air, but mostly kasama na yung interaction of pressure and temperature. So in terms of air, so we'll be using this equation. So saan niya to? It is already shown in your thermodynamics. I hope you can still remember that one. Now for the properties of your P, that will be the absolute pressure. So take note, you can still remember that in your thermodynamics, that will be the absolute pressure palagi. So yun minsan kasi nagkakamali that they do not convert it, or we call it adding the atmospheric pressure in order to obtain the absolute pressure. So yun mostly nagkakamali yung mga calculation natin, especially that given problem that will be in gauge pressure. So in order to get the absolute pressure, you need to add the atmospheric pressure. And the same also we have here, we have also the R, that will be the gas constant. So we have the value of your 287, no? That will be joules per kilogram Kelvin. Then you have your R for your English unit, that will be 1760. That will be pound mass per pound mass put, that will be divided by your slug degree Rankine. Now for the absolute temperature, we have T for your temperature, that is defined as your definition of your T temperature. So for the absolute temperatures, we have your Kelvin, okay? So you just only going to add the 2 degrees Celsius plus the 273. Now for English, sorry, that will be degrees Fahrenheit plus 460 in order to attain an absolute temperature. Okay? So I'm writing here the different types of properties of fluid. We have the different properties. Also, let's say the different density of fluid now. So for your air, we have your given that will be 1.29, that will be kilogram per cubic meter. This is cubic meter, sorry. Now, we have mostly, kasi this will be the different types of fluid na gagamitin natin as we go deeper and deeper into the study of your fluid mechanics. So, you must be fully aware that it has a different, these are the common properties that will be dapat ninyong natatandaan, not mostly like to memorize, but usually be familiarized with it. Right? Next properties, we have the specific volume, or it is symbolizes with this form of symbol. So specific volume, so that is the 1 over the reciprocate of the density of the fluid. Or it can be represented that will be 1, that will be mass over the volume, or it can be as volume over the mass. So that represents the equation ng ng specific volume. So that symbolizes specific volume natin. So the units, for example, we have in SI, it will be so that will be volume, that will be cubic meter, no, per kilogram. Now for English, we have the unit of cubic feet over the pound mass. Okay. Next, we have an third practice that will be needed also, that will be call it the unit weight or the specific weight. Okay. But mostly it will be called a specific weight, and it has a symbol like this. Okay. Now, the specific weight, it is defined as the weight of the fluid and divided by the volume. So we can also express your weight, so that will be W divided by the volume, or this can be expressed as the mass times your gravity divided by the volume, or it can be, since this is mass and this is volume, so that is density, that will be density times your gravity, so that will be 9.81 meter per second squared. And we have the units of your specific weight. So your specific weight units, that will be, call this, that is weight, so that will be Newton, unit niya, Newton cubic meter. So that will be the unit weight, a unit ng specific weight. So for we call this this is for SI. Now for English, it will be pound force per cubic feet, or let's say that will be pound force per cubic inches. Okay. Next, we have the specific gravity. So usually it is a dimensionless. No? So dimensionless. So walang tong unit, dimensionless. Okay. So for liquids, so we have their specific gravity. So sometimes it is symbolizes SG. So automatically, if you see that one in properties of fluid, when we say SG, that automatically call it specific gravity. So we can express your specific gravity. So we have your equation that will be the density of the fluid, okay, divided by the density of your water. Okay. So for gases, so this is for sorry, this is let's change this one. This is liquid. Sorry. So this is liquid. Now for gas, so this is for liquid. Now for gases, we can compute our specific gravity for gases. That will be the density of the gas divided by the density of your air. So that will be for gases. Now for water, so we have the properties of water. So for water at 4 degrees Celsius, so we have the following properties where your specific weight that will be equal to 62.4 pound mass. This will be pound force per cubic feet, and it is also equal to 9.81 kilonewton per cubic meter, where the density of the water will be 1.94, that be slugs, no? Slugs per cubic feet, which is also equal to your 1000 kilogram per cubic meter, where the specific gravity of your water, we have the Sg of your water that will be equal to 1.001. Okay? Viscosity, next we have next properties that will be viscosity, that will be the property of a fluid, so determines the amount of resistance to shear. So when we say resistance to shear, that is yung binding of fluid. So you try to resist, so that is the amount that it can resist to collapse the fluid. So that is the viscosity. Usually that is the technical description, but in layman's terms, so that is yung dakot ng fluid. But in technical term, that is the resistance of a fluid to rupture, or yung when you say rupture is to para maghiwalay sila in layman's term. Okay? Then when we say perfect fluid, so that means that there will be no resistance, there will be no viscosity. So have the viscosity, that will be a perfect fluid, right? Now one of the basic explanation of the viscosity, for example, that we have here, consider we have two large parallel, so large parallel plates. So this one and this one, the one is stationary, so when it's stationary, so there is no bend. The other one is moving plate. Now you have a small distance, we have your small distance y here, and we have the space apart between them, and you have a fluid here. So this is your fluid, and this one is also fluid. So they are being separated by a y distance of a fluid. So y distance, when we say y distance, this is the ideal distance given value, or that will be substituted. Now consider the upper plate to be subjected to a force. So you have a force here, and it is moving now. And so as to move, you have a constant velocity. So you have here the velocity here. So this is the velocity. Then the fluid contact with the upper plate will adhere to it and will move with the same velocity. Right? So when the fluid, we call this as you move along the plate, the same also, it will push also the fluid. If you will move the plate at this direction, the plate, the fluid beneath the plate, the moving plate, also move with the same velocity with the plate. Right? So while the fluid, which this part below, so let's color it different color. So for the fluid which is at this part below, so we'll have a constant velocity that is the same constant velocity or a zero velocity with corresponding with the fixed plate. So the film that is yung kadikit ng fixed plate will have a zero velocity, while the plate, the fluid which is directly in contact with the moving plate gain the velocity the same also that of the moving plate. So for the small values of u, or the velocity and also the distance, the velocity gradient can be assumed to be a straight line. So then varies as and the force varies as your area and your velocity and your distance. So we can give an equation for that one. So we can rewrite an equation. So we can write an equation which is your force. That will be, let's change the color, that one. So that will be your force is, we have a relationship that will be the force that will be directly proportional with your area times your velocity divided by your distance, or your y. Sorry, this is y. Or we can say that the force over the area that will be directly proportional. Sorry. And looking at the figure, but looking at the figure, we have your velocity over your distance, or your distance or clearance is equal to the change in, call this change in the volume v, okay, change in volume divided by the change in distance. So that is from figure. It will be your from figure. Okay. Now we all know, and also we have a relationship, your shearing stress. So your shearing stress, that will be equal to the force over your area, or that will be the symbol tau. Okay. So where we can rewrite it also that your shearing stress, that will be directly proportional with the change in volume, the change in distance. Or we can say that your shearing stress, that will be equal to your K, change in volume, divided by the change in distance, or your displacement that we have. So where the constant of proportionality, this one K, constant of proportionality, that will be called the dynamic of absolute. This will be called dynamic of absolute. Dynamic of absolute viscosity. Okay. And we can rewrite a relationship that our shearing stress, so that will be equal to your absolute dynamic viscosity times the change in volume, then your change in displacement. Then finally we can rewrite the equation for your absolute dynamic viscosity, that will be your shearing stress divided by the change in volume divided by the change in displacement. So this will be the equation now for your, so we have now the equation for your absolute dynamic viscosity. So we have this one. Let's change it. Highlight this one. So we have now the equation for that one. And let's try to define that. So we have this one, that this is your shear stress. So shear stress. So we have in inch, in pound force per square feet, or this will be your Pascal, and this one is your absolute, and we have this symbol, so that will be mu, the absolute viscosity in pound per second per square feet. So it can be also called as poise, or it can be expressed as Pascal second, where your y, that will be the distance. So distance, the distance in plates, between plates in feet or meter, where u, that will be the velocity in feet per second or meter per second. Next, we have the property kinematic viscosity. So we have the symbol here nu. Okay. So this is the ratio of the dynamic viscosity, that will be defined as the. So we have the definition that it will be the ratio of the dynamic viscosity of the fluid, or mu, to its mass density. We have your rho. So we have your equation for this one, that will be absolute dynamic viscosity divided by your density. So that is the kinematic viscosity that we have defined. And we have a conversion here, so take note of this one. We have one poise, that will be 1 times second per square centimeter, which is also equal to 0.1 Pascal second. And we have also one stoke, that will be 0.001 square meter per second. Next, we have the surface tension. So we have the symbol sigma. So that will be the membrane of the skin. So we define as also the seams to be formed, the free surface of a fluid, that will be due to the intermolecular cohesive force. So this is the reason why also, and this gives the reason why also your insects or insect floats to the inner skin, let's say on the top surface of water or seawater. So that is the binding forces on the liquid. Usually usually if you're going to put yung needle in an undisturbed surface of water, usually it just make it sure it is undisturbed. So when it is disturbed, automatically it will lulubog. So pero once it is undisturbed, so dahan-dahan mo siyang, you will be putting it in the stops undisturbed surface of water, it actually floats. So you can try that one also in your home. So that defines the surface tension. This surface tension, there are times that will cause bubbles and droplets to take on a spherical shape. Since any other shape would have more surface area per unit volume, now that now those pressure inside the droplet of a liquid, or inside the bubble, it can be expressed with the equation that will be 4 times the surface tension, then divided by your diameter of the droplet. So we have here the definition that the sigma will be the surface tension, that will be Newton per meter. Then you have D for the diameter of droplet in meters. This is already in meter. And you have your P defined as the gauge pressure in Pascal. Next, we're going to tackle the capillarity, where it is the name given to the behavior of a liquid in a thin bore tube. The rise or fall for a liquid in a capillary tube is caused by the surface tension and depends on the relative magnitudes of the cohesion of the liquid. Then you will have your addition of the liquid to the walls of the pertaining vessel. Now we have the liquid, as the liquid rise in a tube, they wet, so that will be the adhesion So that will be the adhesion is greater than cohesion. Now, if the fluid fall in the tube, they do not wet. So that is the cohesion is greater than adhesion. So typically it looks like this. No? If you have the diameter here of your tube, the water. Now, so we have here. Now we have here your fluid, surrounding fluid. Now here is a bouquet of water. Then you have your angle here of theta. How much is that one? Now you will see the surface of water or fluid compared to this one. So this is when the adhesion is greater than cohesion, and the other one is cohesion, which is greater than the adhesion. So that will be the reactions as you plunge the tube into the fluid. No, sorry, the fluid water. Plunge the tube to the liquid. So that will be the reaction. Now, the capillary is important when using tubes which is smaller than about 3/8 inch or 9.5 mm in the diameter. So we have a given height from the surface of water here. So you have your H, and we have also your H projecting here. So that will be the value of H. Now, to get the value of H or height, so we have the equation. So that will be your H is equal to 4 times your sigma times the cosine of theta divided by your specific weight of your fluid. Then we have your diameter. So we have here now your equation to determine what will be the height, to determine the height of that capillary action. Now, for complete wetting, as with the water on the clean glass, the angle of theta becomes 0. So, complete wetting. Now, what will be the H? So, we can write your formulate your H. So, that will be 4 times the sigma. So, which have that will be 0 already, that we have your specific weight. Then, you have the diameter. So, that is for complete wetting. Equation. For the contact angles of different types of liquid in a glass, right? So we have different types of angle that will be used in the equation. So take note of this table, no? So directly substitute na lang, will be directly substituted onto the equation. We have next properties, compressibility, so also known as the coefficient of compressibility, when defined as the fractional change in volume of fluid per unit of change in pressure in a constant temperature process, where the formula is equal to change in volume divided by negative change in volume over your volume divided by the change in pressure, where it can be expressed as 1 over your compressibility 1 over EV. So that will be EV, that will be the defined as the bulk modulus of elasticity of bulk modulus of elasticity of fluid. Okay. Or we can express your equation as negative change in volume divided by your volume divided by the differential change in pressure. Can be expressed like that. Where your change in volume, that will be the change in volume. Your V will be the original, and the symbol of the change in pressure. So we have here the value of the symbol of the equation. Next we have the bulk modulus of elasticity EB. So that is will be the ratio in change in unit pressure to the corresponding volume change per unit volume, where your EB, or the modulus of elasticity, so expressed as this equation, that will be the stress divided by your strain, and it is equal to your change in pressure divided by your change in volume over your volume, or let's say can be expressed as, or it will be as your ED will be negative change in pressure divided by the differential change in volume divided by V. Next we have the pressure disturbance. So that will be the pressure disturbance imposed in the fluid moves in waves. The velocity celerity of the pressure waves, also known as the acoustical or sonic velocity, is expressed in equation. We have your C, that will be the square root bulk modulus. Then we have your density, which is also equal to the square root of your 1 divided by the compressibility, then multiply compressibility, then multiply by the density. Now, sample problem 1. So, our reservoir of a glycerin has a mass of 1,200 kilogram and a volume of 0.952 cubic meter. So, find its weight. So, for solutions of weight, so we have the given equation. You have your weight. This is basic from your physics. So we have your weight, that will be your W is equal to the mass times the gravity, where our mass, it will be 1,200 kilogram, and it will be multiplied by your gravity, with be 9.81 meter per second squared. So using your calculator, we have 11,772 Newton, or let's say that this is equivalent to 0.772 kilonewton. Next, for letter B, we're looking now for the unit weight. For the unit weight, we have your equation, that will be unit weight is equal to the weight over your volume. So we have your weight that is already being calculated at problem A. Problem A, that will be 11,772 Newton. That will be divided by your volume, which is your volume is 0.952. That will be in cubic meter. Now, using your calculator, so we have the value of 12.366, so kilonewton per cubic meter. Then next, for the density, so that will be symbol of rho, which is equal to now your mass over the volume, where our mass, that will be 1,200 kilogram, and divided by 0.952. So this will be cubic meter. So we have a density of density of, so we have the value of that is 1260. This will be in kilogram per cubic meter. Then next we have this last unknown, specific gravity. So what will we find the specific gravity? So we have your Sg. So that will be the density of the fluid or density of the glycerin divided by density of the water. Now we have already computed the density of the glycerin, that will be 1260. This should be expressed in kilogram per cubic meter, then divided by 1000, the density of water, that will be kilogram per cubic meter. So using your calculator, you get that the answer is, we have the specific gravity, which is now 1.26.